Okay, by definition, you can only test 2 samples at a time, okay, or from 2 different populations. Okay, but if you are comparing 3 or more populations, let's say we want to test the performance of students taking basic statistics from group A, B, and C. Okay, so if it involves 3 groups, then the 2 sample hypothesis testing approach that you learned last week, okay, is not suitable, okay, because okay, it only allows you to test more than up to 2 sample only, or 2 different populations only. So that's where the ANOVA becomes very useful. And in fact, in the real world scenario, in the real world research, okay, many lecturers or many researchers are using ANOVA, okay, instead of the simple 2 sample hypothesis testing, because ANOVA can also do up even for 2 sample hypothesis testing. Okay, so and it is much easier to interpret. And when it comes to software applications, if you use package like even Microsoft Excel or econometric softwares like Stata, eViews, SAS, or any other softwares that can perform econometric calculations, ANOVA is part of the standard output when it comes to the regression analysis. Okay, so that is the focus of our topic, chapter number 10, okay, in your syllabus. And hopefully you will learn the basic of ANOVA, and most probably you will see this application again in your basic econometric subject. And also, okay, maybe later, maybe not this year, maybe next year or 2 years from now, when you learn the research method paper and do your research project, the 6-hour credit paper, okay, for usually meant for when you are in your 7th semester. Okay, so you will, if your research relies on primary data, meaning you do questionnaire and collect your data from questionnaire and do your research from there. So ANOVA will be a very common method, okay, in that kind of research. So what you will learn this week, okay, will be useful, okay, maybe not this semester, but in your upcoming semester, next semester, and also in your 2nd or 3rd year of your degree. Okay, so what we will be focusing for the ANOVA, the most important one is of course the item number 12-4 and 12-5. Okay, whenever we want to do ANOVA for 3 or more groups. Okay, treatments means 3 or more populations. Okay, so we will start with the basic ANOVA first, whereby we will do only for 2 sample hypothesis. Okay, and then the focus of our chapter for chapter 10 will be on the last 3 items here. Okay, and then at the end of the day, okay, you need the purpose of this ANOVA testing is for hypothesis testing as well, just like 1 sample and also 2 sample hypothesis testing that you learned before, and you learn how to answer or how to do a hypothesis testing based on the 5 steps that we okay, based on what the book suggested. Okay, but starting from developing your null and alternate hypothesis. Okay, step 1 until you arrive at step number 5, you do the calculation and come up with the conclusion, the 3 points for the conclusion, whether you reject or do not reject, and what is the meaning of your conclusion. So that will be the same thing as chapter number 10. Okay, so the only difference is that we will apply the F testing instead of Z or T. So what you learned so far in the 1 sample or 2 sample is the use of the Z distribution table or the T table, the student T table. Okay, but for ANOVA, you will be using the F table. Okay, so that will be the main difference. Okay, beside the way you're going to do the calculation is slightly different, because now we involve 3 or more populations, okay, when it comes to do the testing. Okay, so first, so this week or this for today, the goal is to introduce to you what is the F distribution. okay, that will be used to calculate the critical value, the F value, the calculated F value. So far what you have done is you calculate the Z value and also the T value using the formula that you learned previously, X bar minus mu divided by standard error. Okay, but for F distribution, okay, to calculate the F value, it is not as straightforward as calculating T or Z, okay, in the one sample or two sample hypothesis testing. So it requires a little bit more steps to calculate manually. Of course, when it comes to calculation, you can also use the computer program or software, or you can check the online calculator. Okay, for ANOVA. Okay. So let's start with the F distribution. So basically, it is named from the person who based on this Sir Ronald Fisher. So the F stands for Fisher, the name of the person. Okay, so to test whether two samples from populations having equal variance. So what we have done so far in the one sample and two sample test. Okay, if you check from the from our previous chapter on either on the one sample or two sample test, okay, the way you construct your H1 and also your H0 is always in terms of the mean. Okay, so for example, you put mu1 not equal to mu2. Okay, whether it's one for if it is one sample, you put mu1 more than certain value, or mu1 less than certain value, or mu not equal to what value. Okay, but if a two sample test, okay, mu1 equals to not equals to mu2, mu1 is greater than or mu1 less than. At the end of the day, it's always in terms of mean. So that's why we are comparing the population mean, okay, whether it's one sample or two sample hypothesis testing. But when it comes to the F distribution, okay, the mean is not to compare the mean, but we are comparing the variance. Okay, so let me jump to this slide first just to give you an idea how the construct of the H1 and also the H0 testing for equal variance. So this is only meant if you have only two populations. Okay, but the later part of our syllabus, I mean for chapter number 10, okay, when we go back to the actual ANOVA table, we will go back to the normal testing of the mean. Okay, but this time around, if you have more than two or above mean, okay, of course you can also do for two, okay, but we want to highlight the use of F distribution using ANOVA, okay, when it comes to comparing three or more populations. Okay, so in the later part of the chapter, we will go back to the normal testing of the means. Okay, but the first part of the syllabus, okay, we will learn how to compare based on the variance, not based on the mean. So there are two parts of this chapter. Okay, whether the variance of the two populations are equal. So I want to highlight the word two because in the previous chapter you learn on testing, doing the hypothesis testing for two different populations. Okay, so here we will start with again using two, but this time around not comparing the mean. Okay, as what you did before. Here you are comparing the mean. That's why your H1 and your H0 is based on the mean value. Okay, but for the first part of the chapter, we will learn how to do hypothesis testing, but comparing the variance. Okay, not comparing the mean. Okay, and only the later part, okay, that we will learn hopefully by next Monday. Okay, and finish up on the final week on next Thursday. Okay, doing questions on this chapter. Basically, this chapter is quite short, okay, compared to the two sample or one sample hypothesis testing, because the idea of hypothesis testing you already learned in the previous two chapters, from step 1 until step number 5. So basically here we are just focusing on the method, okay, not so much on the 5 steps already, because you already learned that in the previous two chapters. So we will start on doing hypothesis testing when comparing on the variance. Okay. So first, what are the characteristics of the F distribution? So you learn Z distribution and also the T distribution. Both Z and T are under the family of normal distribution. Okay, when we say normal distribution, the shape of the distribution, when you plot the data, it will look something like a bell-shaped distribution. Okay, whereby the mean will be 0 and standard deviation will be equals to 1. Okay, so that is the argument or the characteristics for Z and T distribution. But when it comes to the F distributions, okay, so what is the main difference? Okay, so it is still what we call, okay, so let's go back to this. Okay, to test whether the two samples are from population having equal variance. Okay, so this is your H0, okay, because your H0 will be sigma squared 1 equals to sigma squared 2. So you are testing whether they are having equal variance instead of testing they are having equal mean. Okay, and then comparing several population means simultaneously. This is the call of analysis of variance. So ANOVA, the focus is based on variance. Okay, so that is what we call ANOVA means. Okay, the VA stands for variance. Okay, in both situations, the population must follow a normal distribution, and the data must at least be interval scale. Okay, so interval you learned before the level of data. Okay, you start with ordinal, nominal, ordinal, and then ratio, and then interval. Okay, interval means you can start even at negative value. Okay, so what is F distribution? There is a quote unquote family distribution. So why we put a family? Because the characteristics of F distribution is determined by these two. Okay, the 2 degrees of freedom. In the T distribution, your degrees of freedom is based on the sample size minus by 1. Okay, for a 1 sample test. But for a 2 sample test, your DF will be N1 plus N2. Okay, N1 plus N2 minus 2. This will be your, minus 2. So this will be the DF for a 2 sample hypothesis testing that we learn in chapter number 9. Okay, in chapter number 8, whenever you do a T test, okay, your degrees of freedom will be N minus 1. Okay, so this is the degrees of freedom under the T distribution. Okay, but for ANOVA, okay, under F distribution, you have 2 degrees of freedom. Okay, meaning if you look at the table in your ANOVA, okay, let me just skip to this slide first. Okay, you can check in your ebook. Okay, later on I will show the part from your ebook. Okay, so you can see in a F distribution table, the top row and also the first column is showing you the degrees of freedom for the denominator and also for the numerator. Okay, you know what numerator is the value on top, denominator is the value at the bottom. Okay, if you take a ratio, okay, x over y. So x will be the numerator, y will be the denominator. So this is what we call as having 2 degrees of freedom. Okay, is determined by the 2 degrees of freedom. Okay, and just like Z and T distribution, they are continuous. Okay, because earlier in your syllabus you learn discrete distribution. Okay, 2 types of discrete distribution that we learned, which is Poisson and also binomial distribution. Okay, and then we learn on the Z distribution, which fall under the continuous distribution. So just like Z and T, F is also a continuous distribution, but the main difference is it is positively skewed. Okay, so if you recall what is positively skewed, the tail of the distribution is skewed towards the right. Okay, so you can go back to your earlier lecture notes on this. So what does it mean by a positively skewed distribution? Where is the mean? Where is the mode? Where is the median? Okay, so this is the difference that so The mode is of course the value on the right side, okay, because that will be the value with the highest value. I mean, and then the mean will be in the middle, median will be the value on the left. Okay, so for a positively skewed distribution, the tail of this distribution is pulled towards the right of the distribution. Okay, so this is the main characteristics of an F distribution, and of course it is asymptotic. Asymptotic means the value will not cut the x-axis. It will just go on and on to the infinity, meaning this line will never cut the x-axis. Okay, so that is asymptotic. Okay, so this is just some example that we can use when we are comparing two population variants, okay, not two population mean. Okay, so the F distribution is used to test hypothesis that the variance of one normal population equals to the variance of another normal population. Okay, so why are we interested to compare the variance, not the mean? Because in some scenario or in some condition, we are not interested on the mean. We are interested on the variance. Okay, so you can see this example here. Okay, in the slide. Okay, so for example, there are two. This company is having this machine that produce steel bars. Okay, of the same length. So the bars therefore should have the same mean length. We want to ensure that the addition of having the same mean length, they also have similar variation. So what is the difference between variance? Variance is the difference between for example, if you have 10 students, I mean, for example, use our student class, okay, group A in this subject. So let's say we take the marks, okay, the overall marks towards the end of the semester, and we get the mark of each student, and then we plot the marks. Okay, so if you recall, what is the formula to calculate standard deviation or the variance? First, you must get the value of the mean first. So basically, standard deviation or variance, it measures how dispersed the data is. Okay, so when it comes to situation like this, okay, the mean should be equal, but the company wants to know if the variation is also equal, meaning that from one steel bar to another, okay, so the variation between one bar to another bar should be as minimum as possible, because when it comes to factory, okay, so whenever you produce products in the factory, it is common that uh, from one item to another, there could be some slight variation in terms of the quality, maybe in terms of the length, in terms of the quality. Okay, so that's why let's say if you buy any processed product, for example, one packet of Milo. Okay, so and then in that packet you will see that it will put net weight. Okay, net weight in kilogram, for example, or net weight in gram. Okay, net weight means the product after you deduct the weight of the packaging, it will be, let's say, 0.5 kilogram in that one packet. Okay, sometimes in certain product, okay, they will also mention minimum weight, meaning that the product that you buy might be even more than 0.5 kilogram. Okay, it could be 0.55, it could be 0.6, 0.52. So that is the difference between one packaging to another, because you cannot ensure that every packet of the Milo that you buy, okay, will have exactly the same quantity. Okay, there could be some slight variation in terms of the weight of each of the packet. Okay, due to the machine setting. Sometimes, okay, this is what when it comes to products in factory, you are bound to have some differences. So that is when if you want to do hypothesis testing, okay, in this case, you are more interested on the variance, not on the mean. The same thing here, the mean rate return of two stocks, okay, is, so for example, you are more interested on the variation of the return, I mean of the stock. Okay, so depending on your scenario. Okay, so sometimes you want to test on you are more interested on the mean. Okay, sometimes you are more interested to see on the variance. So this is just some example that that you can find. Okay, so the way to construct the hypothesis testing, if you are interested to test on the variance, will be based on the variance value, which is sigma squared. Okay, we know that sigma denotes standard deviation, sigma squared denotes variance. So if you are testing on two population, so the hypothesis test will be H1 not equal to lah, because you want to test if the variance are equal. So H1 will be not equal to lah. Okay, and then the F value here is very simple and straightforward. So what we do is just take the variance from the first sample, divide with the variance from the second sample. That is how you get the F value, the calculated F value. Of course, okay, when I mentioned earlier in the syllabus, the main focus will be this part, okay, on the hypothesis testing, dealing with 3 or more populations. Okay, so of course, before we go into that 3 or more population, we want to look at how we can apply the F distribution when it comes to testing only 2 population, but this time around, not testing on the mean, but testing on the variance. So we can do that just by taking the ratio of variance from the first sample divide by the variance from the second sample. Again, the way you divide, okay, S squared 1 over S squared 2 is how you the order appears in your H1. Okay, if you put sigma squared 1 first, then S squared 1 will be the numerator, S squared 2 will be the denominator. Okay, so whichever that appear first will be the numerator. The one that appears second will be the denominator. So this is one thing that you need to keep in mind. Okay, so for example, okay, you have this simple scenario. Okay, so uh, we have two companies providing limousine service. Okay, at the airport. Okay, so both are okay, so they have two routes. Okay, dua laluan. Okay, one is via this highway. Okay, and one another this road. Okay, so we want to know how long it takes the time taken. Okay, to reach the destination using two different roads or two different routes. Okay, so for example, if you use your Waze or you use your Google Map, okay, if you can choose different alternative. Okay, option number 1, option number 2, if you want to avoid the traffic jam. Okay, if you want to avoid the highway. So it's the same thing here. So we want to know if there is a difference in the variation in the driving times for the two routes. Okay, so we want to see based on 10% significance level. Okay, is there a difference? So the keyword here is there a difference in variation. So why variation? Because we are not interested in terms of the mean. We want to see what is the between these two between these two routes. How much is the variation in the time? Okay, in terms of the time taken. Okay, to reach from point A to point B lah. Okay, so first the word difference that denotes your H1 will be not equal to sign. And secondly is the word variation, which denotes you are not testing the mean, you are testing the variance. Okay, so your alpha is 10%. Okay, so okay. The steps is the same as usual. You have 5 steps. Step number 1, your null and your alternate hypothesis. So first, focus on the H1, sigma squared 1 not equal to sigma squared 2. So that is what you want to test if there is a difference in the variation. Okay, step number 2, alpha. Step number 3, we are going to use the F distribution. Okay, step 4, the decision rule. Okay, so again, whenever you are answering question for hypothesis testing, in step number 4, you need to fill in what is the value here. So here it is 3.87. Okay, so how do we determine that the critical value is 3.87? First, 6 versus 7. So how do we get 6? how do we get 7? Okay, so let's go back to the example here. Okay, so how many okay, so these are the time taken in minutes. Okay, in row 25. Okay, so 1, 2, 3, 4, 5, 6, 7. So there are 7 items here. Okay, whereby for interstate 75, 7 and 8. Okay, so there are 8 here. Okay, so the degrees of freedom for route 25. So we assume that 25 will be the first sample. Okay, 1 denotes for 25. Number 2 should be referring to interstate 75. So there are 7 samples here and 8 samples for 75. So n minus 1, 7 minus 1, 6, 8 minus 1, 7. So that's how you determine the numerator here. Okay, if you recall just now, the formula will be s squared 1 divided by s squared 2. Okay, s squared 1 will be the numerator, s squared 2 will be the denominator. So when you refer to the F table, the numerator will be the value on top, denominator will be the value at the bottom. Okay, so since we decide that okay, the interstate, the route 25 will be the first sample. Okay, interstate 75 will be the second sample. So 7 minus 1, 6. 8 minus 1, 7 for the denominator. So this is how you refer 6 versus 7 at, okay, I think there is a slight error here. Okay, 3 point, okay. If you look at this table here, it is referring to 5%. Okay, but the point here, we are referring to 10%. Okay, so you need to change here to 0.05. Okay, because there is a slight error there. Okay, so in terms of the slide, they are referring to the 5% alpha, but earlier it shows that they want to test at 10%. Okay, so this should be alpha 0.05, meaning that we are interested to test. If you are based on 3.87, then alpha should be 0.05 or 5%. Okay, so this is one slight error from the book. Okay, so please change in the notes here. You are testing at 5%. The same goes here. You are testing at 5, just to be consistent with what the value from the slide that they are referring to. Okay, so 5%, 6 and 7, 3.87 as your critical value. Okay, the rest is just calculating the variance from the first sample and variance from the second sample. Okay, note that this is the formula to calculate the variance or standard deviation from the sample. That's why you need to divide by n minus 1. So there is no nothing new here. So you learned already before how to calculate sample standard deviation and also population standard deviation. So this one is sample standard deviation because the data is taken from the sample. That's why you need to divide by n minus 1. So once you obtain the sample standard deviation for the first and the second sample, 25 and 75, you take the ratio. Okay, remember it is in terms of variance. So sigma squared. So you get 4.23. Okay, and then the conclusion will be to apply to do the conclusion. Okay, here you see step number 6. Okay, but in reality you can just combine this into step number 5. Just like in the previous 2 chapters, you have step 1 and step number 5. Okay, because in step number 4, when you do the decision rule, okay, by right, okay, based on what you learned before, you need to draw your this area under the curve as well. Okay, as what you see here. So this is the area under the curve. But whenever you are doing for ANOVA, okay, the area under the curve must not be normally symmetrical. It must be positively skewed. The tail of the distribution must be skewed towards the right. Okay, but the rest is the same. You need to show what is the value of the critical value, which is 3.87 based on the table here, 3.87. here 3.866 or 3.87, and then the calculated F that you obtained just now is 4.23. So we conclude that so the value of calculated F is higher than or inside the area of rejection. Therefore, we are going to reject the null hypothesis. Okay, because 4.23 is inside the area of rejection. We conclude that there is a difference because this is what your H1 is. H1 is there is a difference between the two variants. Okay, because we reject H0 means that we can support H1, which means there is a difference between the two population. I mean, there is a difference in the variation of the traveling times along the two routes. Okay, so this is just using the simple uh, analysis of uh, F distribution, but just comparing on the variance, not comparing on the mean yet. Okay, the comparing on the mean, okay, we will cover on next Monday. Okay, so today will just be a short lecture. So I will upload the question for assignment 1, okay, maybe 10-15 minutes from now in your OL, okay, and then you can get together in your group members and discuss how, okay,